Okay, so on that third worksheet, I'm going to do 40 and 14, and then I'll maybe do one or two more. You guys can tell me when to stop, okay, when you're tired of listening. But don't think that worksheet's going to take like a small amount of time. Like an hour is not going to be enough. I would say it's a 3-hour worksheet, probably. So that's how long it's going to take. It's due Monday. So you'll have tomorrow. If you're a junior, you can do that in class tomorrow. If not, you're going to have to do the maps. Sorry about that. But it's not due till Monday, so you have like 5-6 days. Okay? So it should be very doable. But don't think you can like get it done last minute. It won't happen. Okay? All right, so let's have a look. Number 40, I think that's in the top section. Top section shouldn't be too bad. I think that almost none of those. Do any of them have a left-right shift in them? Have a look. Have a look on your worksheet. Do they have a left-right shift in any of them? No, so that top half should go pretty fast. The bottom half, though, all has phase shifts. So that's going to be a little bit tougher, a little bit longer. So I'll make sure I do like 3 of those today, okay? So this one does not have a phase shift. Let's just write down what we know about it. What am I going to do to graph it first? I'm going to have to graph the guide. What is the guide? Cosine. Secant goes with cosine. Great. Okay, so I'm going to graph that cosine. Let's see, so let's write down some information about it. So the amplitude of the cosine is 3, up 1, right? And 2 pi divided by a fourth is 8 pi for the period. Okay, I think that's all we need to know. We just need to graph that, so this one's really not too bad. So 1, 2, 3, 1, 2, 3. Oh yeah, but shouldn't I do up or down first? We'll assemble some tips by the end of class. I think that's one of the tips you should probably do. So it's going to go up to 4, down to -2. Now you guys tell me, is this like a hyperactive wave, or is it a slow, monotonous wave? Why is it slow? The period, how big is this? If you're comparing it to this, how far out should I put 8 pi? Way far, because pi is like 3, right? So that's really like almost 24. Does that make sense to you guys? Like this is way out there. So I'm not going to scale it appropriately, but if I did, well, you know, let's try it. So this would be about 10 maybe, right? And that would be about, I don't know, I'm still too small. But anyway, so 8 pi wouldn't be until you're like way out here around 24, right? So I'm not saying you guys have to make your scale on your graphs appropriate. I'm just, that's the way it really works. Like if you put it in your calculator, is it going to scale it appropriately? Yeah. Yeah, unless you mess around with the window a whole bunch. So it's a good thing to know. All right? Okay, so now I think we can finally graph it. So cosine starts high, starts low, starts in the middle. Starts high, ends high, in the middle. That's at 4 pi, right? It's like 12. Down low at -2. Ends high, in the middle, down low. There we go. And this morning I had some comments from a couple students about, do you really even need to draw the guide? Because they didn't want to waste time drawing the guide. And the answer is no, you don't. But there's one problem you have to think very carefully about if you don't draw the guide, and what is that? The asymptotes. How are you going to know where to put them? Well, where are we going to put them? Aren't we going to put them wherever this crosses the dashed line? Right? So if you don't draw it, I think that becomes a little bit tricky. But where is this technically? It's right in the middle. So you could do it without drawing the guide. I don't advise it though. That is right in the middle. This asymptote is at x equals, and you guys need to label it. Make sure you're labeling everything. 2 pi, and this one's right in the middle of 4 and 8 at 6 pi, and this one is going to be at -2 pi and -6 pi. That's good. Rimmed it. Okay, So remember, none of this even mattered at all except for us being able to get the secant pseudoparabolas. That's what we really cared about. And like that example we did before this, that's what I might put on the test. I'm not going to have the guide in there. If you want to draw the guide in there to kind of help yourself, you're certainly welcome to. That'd be smart, but it's up to you. Okay. All right, any questions on that so far? I think that was just another example of what we've already done. Shouldn't be anything really new. Bless you. Thank you. Let me get another mark. Okay, let's do 14. Okay, this one's a little bit tougher because it has a phase shift, right? It's looking like it goes left by pi over 2. But see, if you said left by pi over 2 and put it in your calculator, you'd see you were wrong. This is sneaky. There's different ways to handle it. I think the easiest way to handle it is to go like this. Somebody tell me what I did. I factored it. Yes? So if you see something like this and you've got a number here and a number here that are doing transformations, you need to factor inside first. Just automatically factor. Otherwise, what you think is going to be wrong. You have to factor that first, okay? Because this isn't going to phase shift left by pi over 2. It's going to be totally different than that. And what else is weird about this one? I picked like the last one in the section, didn't I? So this has to be like the hardest one there is. There's 2 negatives. So what are the 2 negatives going to do? This one's going to make it go like that, and this one's going to make it go like that. Okay? All right, so how do I factor this? I didn't finish the factoring, because I'm betting this one's a little bit tough. What is that going to be? You got a guess, Jade? Minus pi? That's a good guess. So, I assume this is probably a little bit tricky for most of you to factor. Like when I was your age, it would have been tricky for me. So what would I have done? I'd have done just like what Jade did and guessed. And how would you check your guess? Is that times that, that? That times that, what is that, 2 pi? Positive 2 pi? Is this positive 2 pi? No. So is the minus right though? Okay, and then I'll guess again. Pi over 4. Let's try that. So now if we multiply, we get negative 2 times negative pi over 4. What is that? That was the right guess. So most of yours are going to be pretty easy to factor. You're not going to have to think that hard. But if you do have to think that hard, how can you avoid thinking too hard? Just toss something in there and then check it. Once you do 2 or 3 tosses, guarantee you're going to have it. If you are willing to take that much time, it's going to work. But that's only going to be on a couple problems I gave you. Okay? So I made sure to do one with you. Most of them it'll be easy. It'll be like, I don't know, let's see another one on there. What is another one? Oh, like number 10. Number 10's got like cosine 2 pi x plus 4. Oh, it's got a 2 pi in there. See, that's kind of sneaky too. So what would we have to factor out this time? I'm going to pull the 2 pi off. So that's going to be x plus 2 times what is 4? 2. But if I do this right now, wouldn't we get a 4 pi? How do I get rid of that pi? That times that is that. So yeah, you have to do a little bit of guessing though. So I guess that one was a little tricky too. Anyway. Okay. So we finally got it factored. Let's do all the stuff with it now. Alrighty. I need more colors. So amplitude's going to be 3, right? period is going to be 2 pi or pi? Pi goes with tangent and cotangent, right? So we're going to go 2 pi divided by, which one of these? The 2. And you can put the negative on there if you want. Really, that's just a reflection, so I'm going to leave it out. Just like, did we put the negative in the amplitude? No. But if you had, I don't think it would really affect what you get. Like, you'd still get pi, it would just be negative. You'd still be counting by pi's. So we're going to count by pi's. Okay. All right, so I think we've mainly got it. We're going to do negative cosine. I'm going to do everything on this problem but this part, okay? I'm going to ignore that negative until last. There's a lot of things that we've done where I've said ignore stuff, so we're going to put that in our tips. What was one of the things that I said to ignore until last? Always do what last? The phase shift. Good, excellent. You want to do phase shifts last. But see, there's all kinds of things that are kind of last-ish on this problem, so I'm going to actually try to do the phase shift at the same time. Okay? You guys can tell me if you need to stop me if you need to. Okay? So this is a cosine. Is it going to start up or down? It's going to start down. Okay. Okay, so we're going to start down at 3. Okay, so there we go. Then it's going to end down, right? How far is it going to be till it ends down? 2 pi? We said it changed to 1 pi, and right in the middle of theirs, it would be up. Now let's do it with the phase shift all at the same time. So it's going to start down, but where's it really starting? Right by pi over 4. So I'm going to start right and down, and then it's going to end right there, but a little bit to the right. And then right in the middle of those two is going to be where it goes up. Okay? Then, the next period, it would usually be done right here, right? But it's a little bit to the right. Right in the middle, it's going to be up. Then back one, it would usually be done, but I'm going to go a little bit to the right. And I'm going to go up, right, trying to be right in the middle. So there we go. That's a little bit sloppy. This is something like this. Okay, so this one I did this way for a couple reasons. Number one, if you try to do your phase shift and all of your other stuff at the same time, is it difficult? Yeah, I think so. You have to store a lot of stuff in your mind. But that's one of the values of this stuff. Besides learning trigonometry, this is designed to increase your spatial abilities. Yeah, that's what one of the other points of actually doing this is, besides learning the actual trigonometry, which is valuable in itself. But you're trying to increase your spatial abilities here. Okay? Now, I did forget one transformation. Did I do the right pi over 4? Okay, I handled the 2. That was where we got the pi, right? I did cosine, I did the 3, I did the negative because we started down. What did I skip? I didn't do that. What's that going to do with it? It's just going to flip it all over. What's your question? So I have to flip the whole thing over, which once again is going to be spatially challenging. Yeah? So you can start to try to draw a mirror image. Like when I was in high school, I'd have tried it this way because I didn't know of any better and my teachers didn't show me any better. So I'd have started to try to draw a mirror image. Now, like right here, could you do it? Yeah. What happens when you try to start drawing like this piece over here? It starts to make you crazy. It's the same thing, but how do you draw that precisely? You can't just switch anything. It won't work. Now, some of them, see, it's not quite the same. If this was right here, would it be the same and we could just say it's done? Yes. So regular cosine, if you put negative in there, what would happen to it? Like this. This is regular cosine, right? If you switched it like that, what would happen? It'd be a copy switch. You need to do anything? No, that has deep implications for a lot of stuff. Sine, would sine work like that? If you switched it this way, would it change it? Oh yeah, right? This would go there, this would go there, that would go there. You'd have lots of changes, wouldn't you? It'd be like exactly opposite somehow. It's all good stuff to think about, okay? But anyway, this one I think is going to change. How do you make it easy on yourself? 1 point at a time. Move this one here. Move this one, that was like -3/4. Move it there. Move this one there. Move this one. It looks like it's a little past pi, so it's going to be a little past pi. This one's a little before 2 pi, a little before 2 pi. And see, then you can just...
It looks really crazy.
It does. I'm not expecting perfection on this either, right? This is challenging. But, Casey. It is. So reflections and phase shifts in trig land are equivalent. There's formulas that relate them to each other. But we're trying to build intuition so that you could possibly work with that kind of logic. Yes? Good point. Okay, let's do one more, at least. Okay, what other kind of graph should we do? I was thinking a tangent or a cotangent. We haven't done one of those yet. Let's see.
So, that so we just did cosine of that. Was that cosine?
I just did cosine on that.
Oh.
There was no parabolas at the end, was there? Okay, I'm going to do 20 at the bottom. And I have 2 sets of videos from last year on this stuff. You can use those. I'm sure they probably go through some more of the problems on this too, so I guess if you take the time to view them, you'll get some more answers as well, right? But I'm going to tape this all this stuff, so you use it if you need to. And I'm betting most of you will need to. Okay, so this one's a cotangent, totally different shape. What's this 1/2 going to do to it? We just went and did an investigation on that. It's going to make it slightly, instead of going steeper, it's going to be a little bit flatter, but are we really going to worry about that? No, so I don't even think about this part really. What do I do next? Factor, thank you, McLaren. Okay, so in here I factored out the 2. It's going to be minus 2 times what gives me pi? Just throw out a guess. You know? 2. Well, that'd be -4. No?
Pi over 2.
Pi over 2. 2 and 2 would cancel. And would you get minus pi? Yeah. See how you do that? Okay. So we've got a phase shift. I guess I'll write it down. We're going to go right. Just a little, well, might be a lot, I don't know. Right by pi over 2. This thing's going to affect the period. Period on tangent and cotangent starts not 2 pi, but 1 pi divided by 2. Okay, I'm going to ignore the phase shift to see what happens. Like I said, that's a good step. Good tip. All right, so cotangent, does it straddle or does it just sit right next to? Cotangent sits right next to tangent straddles, remember? And we just decided how wide is this going to be? Pi over 2 wide, right? That's how wide this is. So this must be at x equals pi over 2, right? And the next one then, I could keep drawing a whole bunch more asymptotes. Why do I not really want to do that yet? Because I didn't do the phase shift. As soon as you have 1 or 2 asymptotes, now scoot them all over. What happens on this problem? When you do that? Okay? I hear you, sorry. It doubles? What do you mean it doubles? I think that's good. When we phase shift this asymptote right by pi over 2, where's it going to go? Is it going to go here, 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 here? It's going to go and copy onto that one. And where's this one going to go? Onto the next one. And where's that one going to go? So this time, do we get away with something? Yeah, it's kind of like we can almost ignore that, isn't it? It just like copies onto the next one. So that's kind of nice. So now the last thing, we're just going to draw it. Cotangent is go top to bottom, bottom to top. Top, through the middle, bottom. Top, through the middle, bottom. This is at pi, right? And of course it would keep doing that on this side too, don't think it doesn't. And remember, there's a lot of problems that I've been asking you. I don't think any of these problems do, but just keep it in your mind. Remember, you need to be able to count these asymptotes or these intercepts. So if I said, like, what are the x-intercepts of this function? You'd look and say, hey, that one, that one, that one, but there's an infinite number. How can I count that?
Pi over 2 higher.
Where's this in the middle? At a fourth, right? So we could say the x-intercepts are a fourth, or you could have picked this one at 3/4, whatever, plus how far is it to the next one? Pi over 2. You can count it. Look at your picture and say, okay, from a fourth to 3/4 is a half, or you could say plus 2/4, or whatever.
And then you can say n is.
Yeah, you would. Oh, time got away from us. Okay, so use those examples if you need to. We will meet tomorrow, but we're going to do math.